Good morning. Good morning.
Morning, sir.
Shall we start?
Yes, sir.
I told you that I'll begin the procedure to solve the problems by using theoretical method. That is the two types of two ways the problems can be solved. One is by theoretical method. The other is graphical method. We'll talk about the procedure for theoretical method in the today's class. Okay. Give me a moment. Okay. First, he asks us to find the normal stress, that is the stress which is acting. First you give a problem like this. The problem is my voice audible?
Yes, sir.
Okay, there are some internet issue here. Okay, first we will give a problem like this. Adjust for not two classes. I'm doing from laptop. Okay, first it gives a problem like this. The problem uh, will give the problem is the same. A body subject the stress condition can be anything, only normal stresses, only shear stresses, or combination of normal stress and shear stress. I am giving an example for general case. Tau, tau, tau. Okay. Now, now, uh, there is a plane which is at. Before that, I want. We will talk about sign convention later. There is a plane which is at certain angle, theta. Okay. And we need to find the normal stress acting on this plane, the tangential stress sigma t or tau, and then the principal stress sigma p1, sigma p2, maximum shear stress sigma t max or sigma t min. Okay, and he asks us to find the angles of theta p1, theta p2, and represent it with a sketch. Represent it with a sketch. This is how the problem we can give. Okay, sketch in the sense that just two-dimensionally drawing with pen. Roughly, you can draw it. Okay. Since how to approach this, we will follow few thumb rules in order to compatible with the graphical method. We will follow few thumb rules first for our method to be compatible with the graphical method, whether you solve analytically or graphically, to be compatible with the both, I'll follow few steps. First is these things remain the same. Sigma normal, we will calculate it as the formula sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy sin 2 theta. This is sigma normal. First unknown we have found. Sigma t, which we can find it as tau sigma t, or I can write it as tau normal t. I will use this term tau normal t, or I can see tau. You can use one either of this sigma t or tau normal t, or sigma t is given by minus of sigma x minus sigma y by 2 into sin 2 theta plus tau x by cos 2 theta. I'm using laptop. Till now I used desktop. It was very comfortable, but since we are in the college, it took us some time, 1 or 2 classes for me to get adjusted with this. Okay. Principal stresses. Principal stresses can be calculated as sigma p1, which is equal to sigma x plus sigma y by 2 plus root sigma x minus sigma y is one and the same formula by 2 tau square xy. If you take 2 common, 2 is 1 by 4 here, then you have to multiply by 4 here, and 1 by 4 when you take outside the root will be off here. Okay, sigma p2 is equal to sigma x plus sigma y by 2 minus root sigma x minus sigma y by 2 the whole square plus tau square xy. Now we have find sigma 1 and sigma 2, but unfortunately this is the reverse process we are coming, whereas in case of derivation we found the principal planes first and we substituted in sigma normal to obtain the maximum principal stress, but here we can directly calculate it. We know sigma x, sigma y and tau xy, will directly substitute, we will get sigma p1, sigma 2. In order to calculate the planes orientation of principal stresses, there is the principal planes orientation of principal stresses. I use this formula as usual, tan 2 theta p, which is equal to 2 tau xy by sigma x minus sigma y. From this I will be getting theta p1. Okay, from this I will be getting theta p1. Theta p2 is equal to theta p1 plus 90 degree, the 90 degree apart. See, this is very simple. If I write like this is the plane x, this is the plane x y. My theta p1 makes some angle, say 30 degree. This is theta p1. This plane p1. Plane p2 obviously will be perpendicular to this. This is plane p2. Okay, this is my plane. I will represent like this. This is theta p1. This is theta p1 plus 90 degree. Theta p1 plus 90 degree is my plane p2. This angle plus this angle, this angle plus this angle. So with reference to x-axis, we always shift off. This angle plus this angle is my p2. It implies that. Okay. Next, there is some thumb rule has to be followed in this. For example, I'll go here. Uh, okay. See, if the state of stress is like this, the state of stress, the body is subjected to stress like this. This is 50, this is 50, this is say positive only, say 30, 30, 30, 20. I'll follow a thumb rule. This is first, assume this is case A, this is case B. For me to be compatible with my sign convention, that is my graphical method and my this one analytical method to be compatible, I'll be using thumb rules. Okay, two thumb rules I'll be using. This is very simple. You can easily understand that, or you can remember that this is 20 ampere, 50 ampere, 30 ampere. See, in the first case, in the case A, if sigma x minus sigma y is positive, in this case 50 minus 30 is equal to plus 20. Since it is positive, theta p theta p gives the orientation of sigma p1, that is theta p1. If sigma x minus sigma y is positive, we don't know if I calculate theta p1, I don't know whether it's theta p1 or theta p2. Tan of 90 plus theta is the tan if I take, but I don't know whether it is theta, whether it's giving theta p1 or theta p2. If I get a negative sign, that we cannot say it is showing principal stress 1 or principal stress 2. For that, I will be using a thumb rule that if sigma x minus sigma y is positive, like 50 minus 30 is equal to plus 20, then theta p gives the orientation of sigma p1, that is theta p1. This is general case. If sigma x minus sigma y is positive, then 50 minus 30 is equal to plus 20, then theta p gives the orientation of sigma p1. That is, in this is the case. This is the case. This is generally sigma x minus sigma y is positive, then theta p1 gives the orientation of principal plane p1. This is principal plane p1, and 90 degree apart from this is theta p2. Okay. Next, second case B, if sigma x minus sigma y is negative, then in this case 30 minus 50 is equal to minus 20, then theta p gives the orientation of sigma p2, that is theta p is equal to theta p2. Theta p is equal to theta p2. In this case, theta p is equal to theta p1. It means to say that if sigma x minus sigma y is negative, it means that whatever angles, for example, if I calculate tan 2 theta p is equal to that sigma x minus sigma y by some that formula tau by tau xy, if I get say some 30 degree, then this 30 degree is whatever you got is nothing but theta p 2. This is theta p2, which is equal to 30 degree. From the formula we know the theta p2 is equal to theta p1 plus 90 degree, or 30 degree minus 90 degree is equal to theta p1, or theta p1 is equal to minus 60 degree. Okay, so while writing it, what I should write? Sorry, my handwriting is going bad. Unfortunately, this is the first class I'm using by using laptop and writing. This is an inconvenience. Okay, hope up for some time, 1 or 2 classes, I'll get adjusted. So, uh, this is x-axis, this is y-axis. So it means to say that my anti-clockwise rotation was positive. Theta p1 is negative 60 degree. Therefore, theta p1 has to be 60 degree in the clockwise direction. Always I will talk about theta p1. I can also write directly theta p2 is equal to 30 degree. If you are comfortable with that, you can do that. But I will take theta p1, right? Then I will always talk about theta p1, and then I will write theta p2 after that. Theta p2 will be perpendicular to that. This is p2. Therefore, obviously this will be 30 degree, and this is the plane. Okay, have you understood? If sigma x minus sigma y is positive, as in this case, obviously this theta p what you got, whatever theta p you got from this formula is theta p1 only. Directly you can rotate whatever angle you get plus 30 or minus 30, that indicates theta p1 only. If sigma x minus sigma y is negative, then the theta p indicates theta p2. You can write directly, you can indicate by theta p2, but what I will do for our understanding, First I will find theta P1 and then later I will tell the 90 degree to that will be theta P2. Okay. So theta P1 if I find you will get 60 degree. Have you understood this concept? Have you understood this?
Yes, sir.
Have you understood others? Umesh,
Yes.
Prithvi, Arish, Lokesh, have you understood? Mikala?
Yes, sir. Yes, sir.
Okay. Raghavendra, Rakesh, Ritesh, Sugun,
Yes,
have
sir.
you understood? Okay. Shall I go ahead?
Yes, sir.
Okay. Next, we have spoken about the orientation of principal stress. Next, I'll talk about maximum in case if this if I am if I if there's shortage of time, I will reschedule one more meeting. Another 10 minutes I will take, and then we'll wind up this procedure how to find the stresses. Okay, maximum incline shear stress. Why incline in the sense the shear stress are acting in plane. This is in plane. This is in the plane xy plane. If there is a z plus stress also, then it is out of plane stress. We are talking always in plane stress and in plane normal stress, and we cannot call normal stress in plane. That is in plane shear stress. Okay, in plane normal stress can also be there. That is sigma z. Out of plane normal stress, that is sigma z. Okay. Next, maximum in plane shear stress. Maximum in plane shear stress. As usual, little uh, concepts are involved here, but it is same, very easy. First I will find sigma t, which is equal to in foreign other authors call it as tau n t minus of sigma x as sigma y by 2 sin 2 theta s sin 2 theta plus tau xy cos 2 theta. We have followed a your internet connection is unstable. Give me a moment. Now is it audible? And so Unap, you unmute and tell me is it audible? Unap, you unmute and tell me is it audible? Sorry, we had some internet problems here. Is it audible now? Is it audible now?
Yes, sir.
We have some internet issue here. Okay, please manage. So this is maximum inclined shear stress. So what is the convention we followed while the right plotting the maximum inclined shear stress is if 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 sigma t on the internet. Is it audible?
Yes, sir.
Okay. So yes, some internet issue is there. Okay. Shall I go ahead? Shall I go ahead? Shall I go
Yes,
ahead?
sir.
Okay. Please respond. if sigma
Yes,
t
sir.
if sigma t is if sigma t if sigma t is positive, then it rotates the S1 plane in counterclockwise direction. This is the first point to be noted. If sigma t is negative, it rotates the S1 phase in S1 phase or S1 plane in clockwise direction, counterclockwise direction, clockwise direction. We have already discussed. Okay. Next, in order to find the planes of maximum shear stress, what I will do, planes of maximum shear stress. I will not use the formula directly. I will use some. We know that. We know that. I will not use that formula what you have derived in the last class. Tan 2 theta s is equal to minus sigma x minus sigma y by 2 tau x y. I will use this. We know that theta s1 is equal to theta p1 plus or minus 45 degree. When to use plus, when to use minus, I will tell you. Okay. First case. First case, when theta p is positive, therefore theta s is equal to theta p1 minus 45. So it means to say that if this is the xy plane, my theta p makes an angle. If this is the p plane, p1 plane, a positive counterclockwise is positive. This is theta p1. If this is positive, my theta s should be at certain angle. This is theta s, and the difference between these two should be equal to 45 degree. Theta s is equal to theta p1 minus 45 degree. Okay, this is what it means. So if my theta p is theta p or theta p1 is theta p1, sorry, if theta p1 is positive, my theta s is equal to theta p1 minus 45. This is convention you should follow. These are the thumb rules you should follow. Next, second, when theta p1 is negative, theta s is equal to theta p1 plus 45. This is x, this is y. Theta p1 is negative in the sense clockwise. This is theta p. Theta s should be measured in the counterclockwise direction. This is theta s. So that this is s plane, s1 plane you can say, or p1 plane. So that the total difference is 45 degree. Okay, when theta p1 is negative, theta s is equal to theta p1 plus 45. See, I can use the formula tan 2 theta s is equal to minus sigma x minus by 2 tau xy, but it is difficult for you to say which is plane s1 and plane s2. Even though we'll get sigma max and the tau some magnitude, but which is the maximum plane, which is the minimum plane, we cannot say directly from that formula. For that purpose, I am using this thumb rule. These two thumb rules I'll follow. One is for our principal stress and sigma x. This I cannot say sigma x. I cannot say which is the principal. If I get theta p, whether it's theta p1 or theta p2, I cannot directly say. I will follow this thumb rule so that I will come to know which is theta plane p1 and plane p2, theta p1 and theta p2. Just by subtracting, if I get a negative sign, I will come to conclusion that this is the plane theta. It is showing the plane p2. Okay. Similarly, if theta p1 is positive, I will rotate my theta s pen in the clockwise direction, so that the difference would be equal to 45 degree. Total theta s is equal to theta p1 minus 45. If my theta p1 is negative, my theta s, sorry, this is theta s1. Theta s1 will be equal to theta p1 plus 45 degree. Okay, have you understood this?
Yes, sir.
Have you understood this? Okay. Next, as usual, we are left also with the average stress, the planes of maximum shear stress are also accompanied with normal stress, which is given by sigma average, which is equal to sigma x the sigma y by 2. Okay, then finally we should plot, like this. I'll take a general case, standard case. I'll take, this is my x, this is my y, my theta p1 is positive. It is theta p1, the sigma x minus sigma y is positive. This indicates this is theta p1, this is plane p1, and then perpendicular to that will be plane P2, so that sum of this angle will be theta P1 plus 90 degree. Okay, and then I will write the phase, and then I will indicate whatever the magnitude sigma 1, sigma 1, sigma 2, sigma 2. Next, I should also indicate the maximum shear stress plane x, y. If theta s1 is positive, I'll rotate it by counterclockwise direction. Theta s1, this is theta s1, this is plane s1. Perpendicular to it will be plane s2, plane s2. I have to write the plane like this. Okay. If sigma t is positive, it will rotate the plane in counterclockwise direction. S1 face in counterclockwise direction. Obviously, opposite face will be like this, like this. Also, this plane is accompanied with average stress, sigma normal stress, sigma average, sigma average, and sigma average. So this will give you, we'll ask one small derivation, obtain the normal and tangential stress for a body subjected to only in-plane shear stress or biaxial sheet of stress. And one theoretical problem, solve this method by, so obtain the principal stress, principal planes and maximum shear planes and represent it, not graphically, represent it. You'll ask for 10 marks. Okay, so totally 10, one question we can complete. Okay, have you understood this? Have you understood this? Have you understood
So
this?
1 minute, sir. 1 minute, sir. I'm just writing this.
Okay, okay, make a note of it. I will send you this image also. Okay, this whatever I written hard copy, I'll scan, I'll take image and I'll send it to you in Google Classroom, so that you can have a look at it.
Done, sir.
Done? Shall I stop at this point?
Yes, sir.
Once again, I'll conclude for another 2 minutes. I'll conclude this. First, as usual, these formulas are standard: sigma normal, sigma t. There's nothing else, no complication. We can directly find sigma p1, sigma p2. We can directly find. Remember the formula, substitute it. Tan 2 theta p, the orientation of principal stress, theta p1 or theta p2. I cannot directly say whether it's theta p1 or theta p2. What I will do, I will follow a small thumb rule. If sigma x minus sigma y is positive, then it indicates that theta p, whatever we got, that indicates theta p1. If sigma x minus sigma y is negative, then theta p what we got, that indicates theta p2. Okay. Then how to find, if in case sigma x minus sigma y is negative, then how to find theta p2? We know that theta p2 is equal to theta p1 plus 90 degree. I will subtract that theta p 90 degree by 90 degree with theta p2, then we will get theta p1. Next, sigma t. If sigma t we calculate directly from the formula. If sigma t is positive, say plus 50 MPa, then it will rotate the S1 phase in counterclockwise direction. If sigma x is minus 50 MPa, then it will rotate the S1 phase in clockwise direction. Okay. Planes of maximum shear stress. We have found the magnitude of maximum shear stress. We have found the magnitude of principal stresses. We have found the magnitude of the planes of principal stresses. Planes of maximum shear stress is given by this is a formula. Even though there is a formula tan 2 theta is equal to sigma minus sigma x minus sigma y by 2 tau xy. I will not use that because there is no use from it. I cannot say which is a S1 plane, S2 plane. So what I will follow, I will do it. I will follow a thumb rule. If I know theta s, if I know theta p1, if theta p1 is positive, then I will subtract 45 degree from that, so that theta p1 and theta s1 are 45 degree apart, and that gives theta s1. If theta p1 is negative, I will add 45 degree to that, so that theta p1 and theta s1 are 45 degree apart, and from that I will get theta s1. Okay. Finally, I will calculate the average stress. Then I have to represent it. Then I have to represent it just by using sketch. Just draw a line using scale and pencil and indicate the principal stresses, the planes, that angle you should indicate arbitrarily, or you can indicate by using protractor. Sigma 1, sigma 2, and this is 90 degree from this. Theta p1 plus 90 degree is equal to your theta p2. Okay. And similarly also theta s1 plus 90 degree, theta s1 plus 90 degree is equal to your theta s2. Okay, theta s1 plus 90 degree is equal to theta s2. This is theta s2 is plane s2, right? Then this has to be theta s2. Then I will indicate theta s1. The theta s1 is counterclockwise, then it is positive. I indicate theta s1. The average stress, if tau is acting in the sigma t is acting in the counterclockwise direction, it is positive. It rotates the s1 phase in counterclockwise direction. This is the counterclockwise direction. I have indicated that, and the opposite phase I have indicated arrow up, and this completes the sketch. Is there any doubt? Is there any doubt?
No, sir.
Shall I stop at this point?
Yes, sir.
Another 5 or 6 problems I will solve. More than 5 problems is more than sufficient. You can solve any problem of any kind. I'll solve all typical 5 problems. Okay, that should be more than sufficient to complete your third question. First question is complete. Second question also we have completed. Third question I will complete. Another 3-4 classes more than sufficient for me. It's very easy. After giving this basic fundamentals, should not be difficult for you to solve the problems. Okay, I'll stop at this point.